Hi, topic is graph data structure. Graph is very important data structure in computer science due to its innumerable applications in real life scenario like internet. In internet, each router is a node and each edge is a connection between the routers. Moreover, like in social media, like in Facebook, every person in a Facebook is a vertex. If they are friends, then there is a age running between them. So there are a lot of application of graph like in compiler designing, in semantic analysis, in neural networking, in path finding. So we discuss all the application in detail later. First we discuss what is graph. Graph is a non-linear data structure. That means the data items are not arranged in the sequential manner. One data item is connected to several other data items. So, graph can be represented by two tuple V and E, where V is the set of vertices and E will call the set of edges. So, set of vertices and set of edges together specify a graph. See this figure, all circles are the vertices and all lines are the edges. So, there are 5 vertices A, B, C, D, E and there are 7 edges A, B, B, C, A, D, D, E, E, B and E, C. As we can see, there is an unordered pair of vertices. So, A, B is same as B, A. There are two types of categories of graph, undirected graph and directed graph. If all the pair of vertices is unordered, then the graph is called undirected graph. That means if there is an edge between vertex V1 and V2, then it can be represented as V1 comma V2 or V2 comma V1. In this example, the edge can be represented as AB or BA. We can also write AB to BA, edge BC, AD, DE, EB and EC. Next, if the pair of vertices is not ordered, then the graph is called directed graph. That means if there is an edge E between vertex V1 and V2, where V1 is the tail of the edge and V2 is the head of the edge, then it can be represented as V1 comma V2 only, like this. Here edge is AB, BC, CE, EB, DA, DE. So, this is the directed graph. Now, we spend some more time to understand the basic definitions in graph terminologies that are associated with the graph. These are the basic graph terminologies. First is adjacent vertices. A vertex U is adjacent to other vertex V if there is an edge from U to V. That means there is a direct edge from vertex U to vertex V, like this. Here vertex A is adjacent to vertex V because there is a direct edge from A to B, and vertex A is adjacent to vertex C. But vertex A is not adjacent to vertex D because there is no line between A and D. So, it is the adjacent vertices. Next is the degree. The degree of the vertex is the number of adjacent vertices it has. That means the number of edges incident on that vertex. Take an example, A, B, C, D. The degree of A is 2. degree of A is 2 because there are 2 edges incident on that vertex, and the degree of B is 3 because there are 3 edges incident on that vertex, and the degree of C is 3 and the degree of D is 2. But it is the case of the undirected graph. In case of directed graph, there are 2 types of degree, in degree and out degree. In degree is the number of edges coming to that vertex, and out degree the number of edges going outside from that vertex, like this. The in degree of A is 1, there is 1 edge coming to that vertex. The out degree of A is 1 because 1 edge going outside. The out degree of C is 3, there is 3 edges going outside from the C vertex, but the in degree of C is 0 because no edge coming to that vertex. Next is the loop. An edge is called the loop if it has identical endpoints. Like this. The edge E endpoints is A, A. एज ई शुरू हो रही है आपके नोड ए से और एंड भी हो रही है नोड ए पर, देन इट इज कॉल्ड द लूप. नेक्स्ट पैरेलल एजेस. Distinct edges E and E dash are called parallel edges if they connect the same endpoints. Here E can be represented as A comma B and E dash can also be represented as A comma B. So these are the parallel edges. The note is the multigraph is the graph that can have more than one edge between a pair of vertices. मल्टीग्राफ में पैरेलल एजेस एंड सेल्फ लूप दोनों अलाउड होते हैं, बट इन सिंपल ग्राफ नो पैरेलल एजेस एंड नो सेल्फ लूप्स आर अलाउड. This is a multigraph. In multigraph, these are the parallel edges. If this, it will also contain the self loop. Next is the path. Path in a graph is a sequence of vertices like V1, V2, V3 such that consecutive vertices have an edge between them, like this. A, B, C, E, B is a path because there is an edge between A comma B, there is an edge between B and C, there is an edge between C and E, and there is an edge between E comma B. But in a simple path, no vertex is repeated like A, B, E, D. In A, B, E, D, no vertex is repeated. So this is the path. Next is the cycle. A cycle is a simple path if it includes every vertex exactly once except starting vertex. This A, B, E, D, A is a cycle. A is repeated 2 times. A, B, E, D, A is a cycle. B, C, E, B is a cycle. A, B, E, D is a cycle. Next is connected graph. A graph is said to be connected if there is a path between every pair of vertices. आप नोड A से नोड V को विजिट कर सकते हो, नोड A से नोड C को विजिट कर सकते हो, क्योंकि यहाँ नोड A से हर नोड पे जाने के लिए पाथ है, तो इट इज़ अ connected graph. If there is no connection between the vertices, then the graph is called the disconnected graph, like this. We cannot visit B and E from A and D. So, it is a disconnected graph. A graph with one vertex is called the connected graph, and a graph with two or more vertex without any edge is called disconnected graph. Connected components. A connected components is a maximal connected subgraph in which vertices are connected, but there is no path between two subgraphs. These two graphs are connected. ये आपस में connected हैं, पर ये सब ग्रुप आपस में कनेक्टेड नहीं. आप ए से इसको विजिट नहीं कर सकते, डी से इसको विजिट नहीं कर सकते. तो देयर आर टू कंपोनेंट्स बी डी ए डी एंड बी सी ई. नेक्स्ट इज द कंप्लीट ग्राफ. A complete graph is a simple undirected graph in which every pair of distinct vertices is connected by a unique edge. That means from a single vertex we can visit all the remaining vertices by a unique edge, like this. From this vertex we can visit all the remaining vertices by a unique edge. From this vertex we can visit all the remaining vertices by a unique edge. The complete graph is denoted by the Kn, where n is the number of vertices. A complete graph of n vertices has exactly n into n minus 1 divided by 2 edges. A connected graph with n vertices has exactly n into n minus 1 divided by 2 edges. Next, weighted graph. A graph is said to be weighted if the edges in are labeled with some values. It can be a weight or a cost. In the application, weight can be a distance between two cities, the capacity of the cable, it can be a flight time, it can be cost of the two nodes. It depends on the application what it has, like this. Weighted graph can be directed or undirected. In this, 0 is adjacent to 1 with weight 3, 0 is adjacent to 2 with weight 5. In this, all the edges are labeled with some values. Next is tree. A graph is a tree if it has two properties. First, it is connected, and second, there is no cycle in the graph. It is also called connected acyclic graph. There is a unique path between two vertices because it is a minimally connected graph. It is a spatial form the graph in which there is a unique path from vertex 1 to 2. Suppose इस vertex से आपको इस vertex को visit करना है तो there is only a unique path. Next, so these are the basic graph terminologies. Now we discuss ki how to store the graph in the memory. There are two types of, before going to the representation, there are some basic primary operations that are provided by the graph data structure. It is also known as graph ADTs, that is abstract data types, like addition of a vertex, removal of a vertex, get vertex value, set vertex value, addition of an edge, removal of an edge. Next, get edge value, set edge value, displaying a vertex, finding all the neighboring vertices y such that there exists a edge from vertex x to vertex y, and testing whether vertex x is adjacent to y, which means confirming the existing of an edge. It depends on the implementation, what operation do you want to perform. These all are the graph ADTs, that means graph abstract data types. Now we discuss how to store the graph in the memory. There are two data structures are used to store the graph in the memory. First is the adjacency matrix. It is also known as sequential representation of the graph, and second is the adjacency list. It is also known as linked representation. The choice of the representation is a situation specific. It depends on the operation which do you want to perform and easy to use. So, first we discuss what is adjacency matrix. Adjacency matrix A is a V by V matrix defined as if there is an edge between vertex Vi to Vj, the value of Aij is 1. If there is no edge between vertex Vi to Vj, the value of Aij is 0. Consider this graph. The row and columns are labeled by the graph vertices. In matrix, column and rows are labeled by the graph vertices. So, there is an edge from A to A, no, value is 0. There is an edge from A to B, yes, the value is 1. There is an edge from A to C, no, 0, direct edge. A to D, yes, 1. A to E, no, value is 0. Consider node D. There is an edge from D to A, yes, value is 1. D to B, no edge, value is 0. D to C, no edge, value is 0. D to D, no edge, value is 0, but there is an edge from D to E, so value is 1. Here we see in the matrix there are two types of entries, 0 and 1. That is why it is also called bit matrix or Boolean matrix. Here all 0 entries specify that there is no connection between these two vertices. Suppose like this, D to B, there is no edge between D to B. Yes, there is no edge between D to B. And we can also see that all diagonal elements are 0. That means our graph does not contain any self loop. So, this is the adjacency matrix representation of the undirected graph. Next example, what is the adjacency matrix of the directed graph? Same procedure, row and column labeled by the number of the vertices in the graph. A is adjacent to B only, so A to B is 1, all entries are 0. B is adjacent to C only, so B to C के नीचे 1, बाकी सब के नीचे 0. C is adjacent to E, then C adjacent to E, value is 1, all entries are 0. D is adjacent to A and V, यानी कि there is only two edge, D to A and D to E. D to A is 1, D to E is 1. From vertex E to B there is an edge, then E to B the entry is 1. So, this is the representation of the directed graph. Next, weighted graph. So, as we know, the weighted graph can be directed or directed. It depends on the application, and weight can be cost of the fare, the distance between two cities, the electrical capacity of the cable, anything, any value. And adjacency matrix of the weighted graph is used to store the weight of the edges. Here, this is the weighted graph, same procedure, column and rows are labeled by the vertices. There are 5 vertices, 0, 1, 2, 3, 4, 5. 0 is adjacent to 1 and 2. 0 is adjacent to 1 and 2. 0 से 1 के लिए वेट है 3 और 0 से 2 के लिए वेट है 5. 1 is adjacent to 3 only and weight is 2. 2 is adjacent to 3 and weight is 1. 3 is adjacent to 4 and 5, weight is 4 and 8. 4 is adjacent to 6, weight is 6. And vertex 5 is not adjacent to any vertex, that means all entries are 0. So, this is the adjacency matrix representation of the weighted graph. Next, what are the advantages of adjacency matrix? First, it is easy to use and implement. It is very convenient to work because to add and remove an edge, can be done in order of one time. Actually, in a matrix, यदि दो वर्टेक्स के बीच में एज है तो एंट्री है हमारी 1 और यदि दो वर्टेक्स के बीच में एंट्री एज नहीं है तो एंट्री है 0. आपको एज को ऐड करना है तो 0 की जगह एंट्री करनी है 1 और रिमूव करना है तो 1 की जगह करनी है 0. तो इट कैन बी डन इन अ कांस्टेंट टाइम, सो द कॉम्प्लेक्सिटी इज ऑर्डर ऑफ 1. नेक्स्ट एडवांटेज, queries like whether there is an edge from vertex u to vertex v. दो वर्टेक्स के बीच में एज है या नहीं, तो मैट्रिक्स में आपको किससे पता चलेगा कि उस वर्टेक्स के करस्पॉन्डिंग एंट्री 0 है तो एज नहीं है, और उस वर्टेक्स से उस वर्टेक्स के करस्पॉन्डिंग 1 वैल्यू है, दैट मीन्स देयर एग्जिस्ट अ एज. तो इट कैन ऑल्सो डन इन ऑर्डर ऑफ 1 टाइम. So, it is also a advantage of the adjacency matrix. Next, what are the disadvantage of adjacency matrix? Adjacency matrix consume huge amount of memory for storing big graph. Actually, there are two categories of graph: sparse and dense. In a sparse graph, the number of edges are very less. That means the number of edges equals to almost order of v. And dense graph are those graphs in which the number of edges are very large. It is almost a complete graph. ज़रूरी नहीं है complete हो, लेकिन almost. That number of edges equals to order of v square. So, it is not optimal for the sparse graph, क्योंकि sparse graph में क्या होगा कि most of the entries हमारी क्या होंगी 0 और dense graph में most of the entries हमारी क्या होंगी 1. तो it is best for the dense graph, not for sparse graph. Next, insertion deletion operation are not much easy as compared to link representation. Insertion and deletion operation, suppose आपको अपने ग्राफ का साइज इंक्रीज करना है, यानी कि नंबर ऑफ वर्टिसेस ऐड करने, तो मैट्रिक्स का साइज आपको रीसाइज करना पड़ेगा, जहाँ तक हो सकता है आपको रीऑर्डर भी करना पड़े, तो इट कैन विल टेक टाइम. सो इट इज़ द बिग डिसएडवांटेज. Next, the next drawback of the adjacency matrix is that in many algorithm you need to know the edges adjacent to that current vertex. आपकी यदि एक क्वेरी है कि इस पर्टिकुलर वर्टेक्स पे कितने वर्टेक्स एडजेसेंट हैं, तो उसके लिए आपको पूरी रो को विजिट करना पड़ेगा. तो ये कितना टाइम लेगा? ऑर्डर ऑफ वी, जितने नंबर ऑफ नोड्स हैं, क्योंकि हमारे कॉलम किससे एसोसिएटेड हैं? vertices से, तो it will take order of v complexity. So this is the major drawback. To overcome this disadvantage, we use adjacency list. It is also known as linked list representation of the graph. In adjacency list, there are two types of graph: directed, undirected, or weighted graph. For directed and undirected graph, the node will contain two fields. First is the data field and second is the adjacency list field. Adjacency list is the list of vertices that are adjacent to that vertex. In weighted graph, the node will contain three fields. First is the data, second is the weight of the edge and third is the adjacency list. इस वर्टेक्स से कौन कौन से वर्टेक्स एडजेसेंट हैं? Take an example like this. This is an undirected graph. The size of the array is same as the number of vertices in the graph. There are 4 vertices in the graph, so size of the array is 4. 0, 1, 2, 3. 0 is adjacent to 1, 2 and 3. ऑर्डर कोई सा भी आप यूज़ कर सकते हैं, बस इतना है कि 0 एडजेसेंट है 1 पे, 2 पे एंड 3 पे. तो 0 इज एडजेसेंट टू 1, 2 and 3. After that there is no adjacency list, so adjacency list field will contain null value. Node 1 is adjacent to 0, 2, 3. 0, 2, 3. No more nodes, then adjacency list field will contain null value. Node 2 is adjacent to 0, 1, 3. 0, 1, 3. Node 3 is adjacent to 1, 0, 2, 1, 0, 2. So this is the adjacency list representation of the undirected graph. The size of the array is same as the number of vertices in the graph, and each entry of the array will contain the linked list of the vertices that are adjacent to that vertex. Next, linked list representation of a directed graph. Same, there are 6 vertices, then size of the linked list is 6. Node 0 is adjacent to 1, 2 and 3. V0 is adjacent to 1, 2, 3. 1 is adjacent to 4 only. After that, the adjacency list will contain the null value. Node 2 is adjacent to 5 and 4, 4 and 5. After that, it will contain null value. And node 3, V3 is adjacent to V4 and V5. Then V4, ये जो order है, आप V5 या V4 को कैसे भी लिख सकते हैं, बस it will tell us there are 2 adjacent vertices. Node V4 and V5 is not adjacent to any vertex. That adjacency field will contain the null value. So this is the representation of the directed graph. Next is weighted graph. So as we know, the weighted graph is used to store the weight of the edges. So every node will contain 3 fields. First field is the data field, second is the weight, and third will contain the address of the next adjacent node. So there are 6 nodes. The size of the linked list is 6. 0 is adjacent to 1 and 2. 0 is adjacent to 1 and 2. For 1 the weight is 3 and for 2 weight is 5. After that it will contain null value. Node 1 is adjacent to 3 and weight is 2. Node 2 is adjacent to 3, weight is 1. 3 is adjacent to 4 and 5, weight is 4 and 8. After that adjacency field will contain null value. 4 is adjacent to 5, weight is 6, After that, adjacency field will contain null value. Node 5 is not adjacent to any vertex, so the adjacency field will contain null value. So this is the linked representation of the weighted graph. Now next, what are the advantages of the adjacency list? First, adjacency list allow us to store graph in more compact form. Means if there is an age, it will store in the adjacency list. If there is no age, there will be no entry like this. एडजेसेंसी मैट्रिक्स में यदि एज नहीं भी है तो आपको एंट्री करनी पड़ रही है 0, पर एडजेसेंसी लिस्ट में सिर्फ उन्हीं एजेस की आपको एंट्री करनी है जो प्रेजेंट है. सेकेंड, इट हैज़ अ स्पेस कॉम्प्लेक्सिटी ऑर्डर, स्पेस कॉम्प्लेक्सिटी v plus e, like this. The space for this is the number of ages for this e, and this array is of size v, so space complexity is order of v plus e. Next advantage is that adjacent list allow to get the list of adjacent vertices. एक वर्टेक्स पर कितने नोड एडजेसेंट हैं, 0 पे कितने नोड एडजेसेंट है, ये आपको सिर्फ एक एंट्री 0 ऑफ 1 टाइम में कांस्टेंट एंट्री में आपके पास पूरी की पूरी लिस्ट आ जाएगी कि ये नोड इस पर एडजेसेंट है. लेकिन एडजेसेंसी मैट्रिक्स में यदि ये एंट्री लेनी है तो आपको ऑर्डर ऑफ v टाइम लेगा, क्योंकि आपको उस वर्टेक्स के करस्पॉन्डिंग पूरी रो को ट्रेवर्स करना पड़ेगा. सो इट्स अ वेरी बिग advantage of using adjacency list. Next, what is the disadvantage of adjacency list? It is harder to check whether a given age in a graph. There is an age between two vertices is a very time consuming in adjacency list, because in this case we want to traverse the all link list, but in the adjacency matrix if they just check out the that vertex to that vertex entry, यदि दो वर्टेक्स के बीच में एंट्री 1 है तो एज है, एंट्री नहीं है तो 0 है, तो वो आपको कांस्टेंट 1 टाइम में पता चल रहा है. लेकिन यहाँ पे यदि एज एग्जिस्ट करती है या नहीं, उसके लिए आपको पूरी लिंक लिस्ट को ट्रेवर्स करना पड़ेगा. और ये कितना होगा, ऑर्डर ऑफ v, जितने नंबर ऑफ नोड्स होंगे तो वर्स्ट केस क्या होगा, ऑर्डर ऑफ v. सो व्हाट इज द डिसएडवांटेज ऑफ यूजिंग एडजेसेंसी लिस्ट? फर्स्ट, इट इज हार्डर टू चेक वेदर अ गिवन एज इज इन द ग्राफ. किसी ग्राफ में इस वर्टेक्स से इस वर्टेक्स के बीच में कोई एज एग्जिस्ट कर रही है या नहीं कर रही है, उसके लिए आपको पूरी लिंक लिस्ट को ट्रेवर्स करना पड़ेगा. वर्स्ट केस में इस लिंक लिस्ट में कितने नोड्स हो सकते हैं, नंबर ऑफ वर्टिसेस, देन ऑर्डर ऑफ v. बट इन केस ऑफ एडजेसेंसी मैट्रिक्स देयर इज एन एज बिटवीन टू वर्टिसेस is exist or not, just check the entry is 0 or 1, so it will execute in 0 and 1 time. So this is the very big disadvantage of the adjacency list. So final conclusion is that adjacency matrix is good for the dense graph and adjacency list is good for the sparse graph. Now we discuss some of the applications of the graph. Graph are used to solve many real life problems, like in social networking. In social media, graph that represent who knows whom, who communicates with whom, who influence whom, or other relationship in social structure. In transportation network, in road network, vertices are the intersections and edges are the road segments between them. For public transportation, networks vertices are the stoppages and edges are the links between them. Such networks are used to find the best route between the locations. Next application is in utilities system like gas connection, the internet, and the water network are the all examples of the graph where vertices represent the connection points and edges are the wire or pipes between them. It is also used in network packet traffic graphs. In this, vertices are the IP addresses and edges are the packets that flow between them. Such graphs are used for analyzing the network security and tracking criminal or non-criminal activity. It is also used in the document graph. The best example is web pages. Web pages is a vertex and each hyperlink is a direct edge. Link graphs are used to analyze the relevance of the pages, the best sources of the information and good link site. It is also used in the neural network, and neural network are used to understand how our brain works and how connection change will when we learn. It is also used in the dependence graph. Graphs can be used to represent dependencies among the items. Such graphs are often used in large projects in line out what components rely on other components and used to minimize the total time or cost of completion. It is also used in compiler design. They can be used for the data flow analysis and register allocation. It is also used in the semantic networks. In this, vertices represent words or concepts and edges represents the relationships among the words or concepts. These have been used in various models of how humans organize their knowledge. Now, these are the some of the applications of the graph. Next, just review the lecture. The question, try yourself the question. First is, which of the following is an advantage of adjacency list representation over adjacency matrix representation? Option 1, in adjacency list representation space is saved. Yes, space is saved because in adjacency list we store only those entries that are present in the graph. यदि age present है तो entry है, यदि age present नहीं है तो there will be no zero entry. Option 1 is right. Second, DFS and BFS, it is a graph traversal techniques can be done in order of V plus E time for adjacency list, and for adjacency matrix it is takes order of V square. Yes, in our adjacency matrix the row and column are labeled by the number of vertices, so maximum time order of V square. But in the adjacency list, vertex array is associated with the array of the edges, so time is order of V plus E, so option B is correct. Third, adding a vertex in adjacency list representation is easier than adjacency matrix representation. यदि एडजेसेंसी मैट्रिक्स में आपको कोई वर्टेक्स ऐड करना है तो आपको पूरी मैट्रिक्स का साइज रिसाइज करना पड़ेगा, लेकिन एडजेसेंसी मैट्रिक्स में सिर्फ आपको ऐड नोड इन द लास्ट एक एल्गो लिखनी है, उसके लिए आपको कोई भी साइज, ये रन टाइम में हो जाएगा, लेकिन एडजेसेंसी मैट्रिक्स में ये रन टाइम पे नहीं होगा. सो ऑप्शन थर्ड इज राइट. सो ऑप्शन डी इज ऑल ऑफ द अबव, सो आंसर इज डी. नेक्स्ट क्वेश्चन इज, given an undirected graph G with V vertices and edges, the sum of the degree of all the vertices in undirected graph each edge is counted twice. It can be represented as a AB or it can be represented as a BA. So, sum of the degree of all the vertices is 2E. The answer is B. Yes. Next, what is the maximum number of edges in an acyclic undirected graph? Acyclic undirected graph, that means it can be a tree that is minimally connected. So for n number of nodes, there is n minus 1 edges in the acyclic undirected graph. The option is A. Next, a graph with all vertices having equal degree is known as regular graph. मल्टी ग्राफ वो ग्राफ होते हैं जिसमें कोई सेल्फ लूप और पैरेलल एजेस अलाउड होती हैं. रेगुलर ग्राफ वो होते हैं जिसमें हर वर्टेक्स की डिग्री सेम होती है. नंबर ऑफ डिग्री मतलब नंबर ऑफ एजेस इंसिडेंट ऑन दैट वर्टेक्स. सिंपल ग्राफ में पैरेलल एजेस और सेल्फ लूप अलाउड नहीं होते हैं. और कंप्लीट ग्राफ, इन कंप्लीट ग्राफ वन वर्टेक्स हैज़ यूनिक एज to all other remaining vertex. So option is B. Option is B. Next is the number of elements in the adjacency matrix of a graph having 7 vertices. So as we discussed, in adjacency matrix, the row and the column are labeled by number of vertices. So there are 7 vertices. 7 into 7 is 49. So answer is 49. Option is D. So this is the basic concept of the graph data structure and how to store the graph in the memory. So thank you. For any query you can contact on in this email ID.